In these two examples of integrals, we are doing some more trig ones, but these are going to be a little bit trickier than some previous ones. Just not as obvious of what am I turning into my u, what am I replacing, those types of things. So um, first off, we have these trig values. So it would be helpful to know what they might have came from. And so in other videos, we talked about doing just all right, but getting rid of the p. So this was, if we did the derivative of tangent, we would get secant squared, which also means if we have secant squared and we do the antiderivative, we get tangent. So if we were to have secant tangent, the antiderivative of that would be secant, right? And so then we were able to build another version from this. So this is secant tangent. So I can make this into a cosecant, cosecant, cotangent. The difference is I just need to make sure that I have a negative on there because when you're doing derivatives of cotangent or cosecant, you're doing a derivative of a co, which means you have a negative on it. So derivative of cosecant was negative cosecant cotangent. Derivative of cotangent was negative cosecant squared. So we have this cosecant cotangent, right? So let me do one little bit of manipulation that we have cosecant, cotangent, and then I'm going to pull that x next to the dx. Okay, because there's some other things that I'm kind of looking for. So what I'm sitting with is a cosecant cotangent that I'm going to be going backwards in my integral. So I'm going to be doing the integral of this minus the negative sign. I'll have to bring the negative sign into it because it currently doesn't have a negative sign. And I'll be bringing it back to a cosecant, because if I do the derivative of cosecant, I would get cosecant cotangent. So this came from just a regular cosecant, which means this is our inside because it's a chain rule. So RU is just going to be the x squared term. And another reason why I know that is when I do my derivative of x squared, I get 2x dx, and that is perfectly lined up right there. So there's another indicator that I'm picking the right u. So let me do one last thing. Let's pull the 2 over to the other side. So it's 1/2 du x dx. So if I rewrite this, I have a 1/2. So that 1/2 is here. And then I'll have a du subbing out the rest of that. But this is going to be cosecant u cotangent u. And then the rest of that just becomes du. So I do my antiderivative. And so I have a 1/2 still. The antiderivative of cosecant cotangent is the negative cosecant. And then I can put the u back in. So we're looking at a negative 1/2 cosecant x squared plus c. All right, let's do this other one. So we have a secant squared, right? And so part of this again is kind of just recognizing what we have. That I do have a secant squared and I have some tangents. So if I let my u equal tangent, and if I do the derivative of tangent, I get secant squared. So I can let my u equal tangent. So let me rewrite this a little bit. That if I just take this one, tangent of x over 9 to the 7th power. So if I do the derivative of tangent, I would get secant squared. Okay, so the derivative of u du Now, the tricky part is I kind of have a chain rule within a chain rule because of this x over 9. Right, so it has its own potential substitution that we got to take into consideration. Um, so if I do this, so tangent of x over 9, my du is secant squared x over 9, which is perfectly that piece, but then you still have this derivative of x over 9, which is going to be 1/9. And I'm like dx tacked on at the end. So I'm trying to isolate secant squared dx, which means I need to multiply a 9 over to the other side. So 9 du is equal to secant squared x over 9 dx. So that matches that. Perfect. So I'm going to be replacing tangent of x over 9 with 9 du. So 9, that's going to be u to the 7th du. So tangent is u. There's our u to the 7th. And then the 9 du is coming from this being replaced. All right. It's antiderivative. So we'll add our power, divide by our power. So u to the 8th divided by 8 plus c. So this becomes 9/8 tangent to the 8th power of x over 9 plus c. And that is our other, definitely more challenging trig 2 problems.